Good morning, kiddos. So today we're going to focus on the algebraic representation part of dilations, right? So we touched on it a little bit yesterday, but we're going to go a little bit deeper today, okay? So recall from yesterday that the scale factor is represented by the letter K, and it's the ratio of the length of any side in the image to the length of its corresponding side in the pre-image. It describes how much the figure is enlarged or reduced. Remember, we said that if k is less than 1, it's reduced, and if k is larger than 1, it is enlarged. So let's add on to that. Using that scale factor, you must be able to write an algebraic representation that describes the dilation. An algebraic representation is a rule. All algebraic representations will start like this: x, comma, y, and then it'll have the arrow. This means the original point. So it originally is x, comma, y, and then the arrow means it's going to change to something else. To write an algebraic representation of a dilation, you must first select two corresponding points, then find the scale factor. So for scale factor k, the algebraic representation of the dilation is going to be x, comma, y, and it will change to kx, comma, ky. Remember, k is standing in for scale factor, right? So whatever the number is going to be here is going to be that same number here. These numbers will always be the same exact numbers. K here and k here will always be the same exact numbers. If you get two different numbers, you're not correct. For enlargements, k is greater than 1, and for reductions, k is less than 1. So let's look at some examples. This would be a good time for you to stop and pause and try these on your own. All right. So in order to find the scale factor, remember we said the new side over the original side, or you'll see the image over the pre-image, new over old, all of the above. Okay, so what we're going to do is get two corresponding sides, right? So if I use this 12, then I would have to use this 24. I cannot use this 12. Why? Because this 12 is a y and this 12 is an x. And corresponding, we want them both to be y's, right? So for my new side, I'm going to use 12. And I know that this is my new side because it has this apostrophe here, right? So if I did 12 over 24, I should get a half, right? Just 1/2. So if I get 1/2, we know that that's less than 1, and that is going to be a reduction. And it'll be the same thing. So if I chose to do 6 and 12 right here, this x over divided by this x, 6 divided by 12 is 1/2 as well, right? Let's look at the scale factor right here. 9 divided by 3, you get 3. 3 divided by 1, you get 3. So that's going to be an enlargement, right? Remember, this is my new over my old, my new side over my original, my image over my pre-image, okay? And remember, y with y, x with x. 15, which is my new, divided by my old, which is 7.5, and I should get 2. And same thing here. 5 divided by 2.5, I will get 2, right? So we'll see how that looks in a second. And then the last one, same thing. 5 over divided by 25, I should get 20 hundredths. And 1 divided by 5, I get 20 hundredths, right? So let's see how that looks in algebraic representation. So remember, x to y changes to, here's what my scale factor is for A, and it's going to stay the same. Remember, the numbers have to be the same. The numbers have to match. Okay? That is all I have for you guys today. If you have any questions, comments, or concerns, please let me know. Have a good day.